So we've looked at simplifying and factoring and multiplying by a conjugate, but sometimes we see some other things that are a little bit goofy too. So let's say we had the limit as x goes to 1, excuse me, of 1 over x plus 1 minus 1/2, and all of this is divided by x minus 1. Again, direct substitution on here is not going to be a great idea because I'm going to get half minus half, which is 0, and then 1 minus 1, which is 0, so I get 0 over 0. But one thing I can do is I can just simplify that thing, right? So I've got this big, long, complex fraction, but it's really not that scary. First thing I want to do is I want to get common denominators so I can add those or subtract those. So this is equal to the limit as x approaches 1 of this denominator is 2, so I'm going to go ahead and multiply this term by 2 over 2, right? That's multiplying by 1, and this denominator is x plus 1, so I'm going to multiply this term by x plus 1 over x plus 1. And so what that gets me is 2 over 2x plus 1 minus x plus 1. But this is the same denominator, right? That was the whole point of that. So this is also 2x plus 1. So I've already got that. And then this whole thing is divided by x minus 1. Well, now I'm going to go ahead and multiply by the reciprocal instead of divide, right? So that's limit as x approaches 1 of 2 minus x plus 1, which we could simplify, we'll leave it for now, over 2 times x plus 1 times the reciprocal of x minus 1, so times 1 over x minus 1. Now let's simplify and see what we have. So this is equal to the limit as x goes to 1 of 2 minus x plus 1, which would be x. This is 2, that x plus 1 is in parentheses because we're subtracting that whole thing. So 2 minus x, excuse me, plus 1, 2 minus x minus 1, that's all multiplied by 1, over 2 times x plus 1 times x minus 1. Now, I still can't do direct substitution here because if I put in 1 I get 0, and if I put in 1 I get 0. But let's simplify. So 2 minus x minus 1 is equal to negative x plus 1 over 2 times x plus 1 times x minus 1. We're still not out of the woods yet. I should still have my limit in here. But if I factor the negative out of this thing, this equals the limit as x goes to 1 of negative x minus 1, right? If I multiply that negative through, I get negative x plus 1, which is what I started with. And then down here I still have 2 times x plus 1 times x minus 1. Now my x minus 1's cancel, and so I have, this is equal to the limit as x goes to 1 of negative 1 over 2 times x plus 1. Well, now I can do direct substitution. I just put in 1 for x and I get negative 1 over 2 times 2, which is negative 1/4. So I just simplified that big long fraction, and that allowed me to use the limit laws to find the limit of this function at x as x approaches 1. What happens if we've got something a little bit complicated, like say the limit as x goes to 0 of 1 over x plus 5 over x times x minus 5. Okay. If we look at this limit, this one's a little bit different because it's not approaching the indeterminate form 0 over 0. It's actually approaching, we've got 1 over 0 plus, if we put in 0, 5 over 0, which we can't do anything with because we are not allowed to divide by 0. So we've got to do a different method here to try to solve this. But what if we just go ahead and added these two fractions together? Let's do the operation. So instead of taking the sum of the limits, let's take the limit of the sum. And so what we see is we're going to need to multiply this term by x minus 5 over x minus 5 so that we get a common denominator. So this is the limit as x goes to 0 of x minus 5 over x times x minus 5, and then plus 5, right? And so this is equal to the limit as x goes to 0, equality exists here, of x over x times x minus 5. And it might look like we haven't accomplished a lot, but now I have an x over x. I can cancel those, so this is equal to the limit as x goes to 0 of 1 over x minus 5. Now I can do direct substitution and get negative 1/5. And so this was an interesting one because initially with the limit laws we couldn't do anything, but then we just added it together by getting a common denominator, and then we were able to get a value for the limit. This limit does exist.